All right, so we're going to talk about solving the velocity equations. Before you can solve velocity, you have to solve position, and there's lots of ways you can do that. It's a triangle, so you can use trigonometry. You can measure the lengths. You could use use your vector equations and use solver. That actually is going to be covered in another question on this. So if this was in class, you'd just be taking measurements. For the take-home, I may give you a CAD drawing to work with these. We're not going to focus on that for this part of the problem. One point that we do need to focus on is the fact that I give you R4, that your input is length 4 moving to the left. So that's information at 0.5 centimeters per second. Now, it's moving leftward, so you might think that's negative, but you have to look at the vector. And in the vector drawing, you can see that if length 4 moves to the left, that this vector is going to get longer. And so that means that has to be a positive R4 dot. So R4 dot is negative, but e to the I, theta, is 180. So it's a positive R4 dot in the negative direction. So the negative is taken care of by the e to the I theta 4 term. So we have R4 dot is equal to 0.5 centimeters per second, and that's positive. Okay, so now when we work on solving this, we know R4 dot, and we're going to be solving for R3 dot and omega 2. So let's do omega 2 first. So we're going to eliminate R3 dot term by multiplying by e to the minus I theta 3. And that will give us R2 omega 2 e to the I theta 2 minus theta 3 plus R3 dot, and that will be equal to R4 dot e to the I theta 4 minus theta 3. We'll then take the imaginary part, and that will give us R2 omega 2 cosine of theta 2 minus theta 3 plus 0, and that's going to be equal to R4 dot sine theta 4 minus theta 3. And that's going to be an easy equation to solve, because we'll just have omega 2 is equal to R4 dot sine theta 4 minus theta 3, all divided by R2 cosine theta 2 minus theta 3. Our next thing we're going to solve for R3 dot. And so we'll go back to our velocity equation right here, and we'll multiply that by e to the minus I theta 2, and that will give us R2 omega 2 I. Actually, this should have had an I in it. I did that term correctly, but left out the I when I wrote that. I have R2 omega 2 I, and this is going to be, that's all you'll have. And then we'll have R3 dot, e to the I theta 3 minus theta 2, and that will be equal to R4 dot, e to the I theta 4 minus theta 2. And let's see here. Yeah. There's also should be an I there. Anyway, I then can take the real part, and that'll give me 0 plus R3 dot cosine theta 3 minus theta 2 equal to R4 dot cosine theta 4 minus theta 2. And I can solve that in turn for R3 dot, as R3 dot is equal to R4 dot cosine theta 4 minus theta 2, and that's going to be divided by cosine theta 3 minus theta 2.